Welcome back. This is an Aleks training video on calculating the pH of a weak acid solution. So you remember a weak acid doesn't break up all the way. It doesn't completely dissociate. This is acetic acid here. This is what's in vinegar. And if you were to put it in water, it doesn't completely break apart. It breaks apart some, and this H will come off, join with the water to make hydronium, and then whatever's left over becomes the conjugate base. So in order to find the expression for the constant, it's going to be your products raised to the power of the coefficient. Now all these are ones happen to be. I balanced this, but there's no coefficients. So this would be hydronium raised to the 1 power, and then this is acetate raised to the 1 power, and then this is the acetic acid raised to the 1 power. So the K sub A, or the acid constant, is the products of the products of the products divided by the products of the reactants. So this is the expression. Now you're given the K. K sub A equals 1.8 times 10 to the 5. But I don't know what to put in here yet. This is an equilibrium constant. So this is only at equilibrium, and you're not at equilibrium when you have this original. That's why you need an ice table. The ice table, though nobody likes it, is really the only way to organize your thoughts so that you know what is these concentrations at equilibrium, because nothing else works. The math would be all wrong every other way. So I'm able to put some things in. Okay, so let's look at what we can put in. Okay, so I have initially 4.5. Okay, and what else? I've got 0 because this is on the right, and then this is 0 because it's on the right. So remember, I have pH. I'm asked to calculate the pH. So I want to get the pH, I have to have the concentration of the hydronium. So that's why this has to be X. That's what I'm trying to find. When I can find X, then I've got the concentration of that, and I take the negative log, and I'm done. I've got the pH. So I can find X. Now, remember, this goes back to the balanced equation. So I've got a 1-to-1 relationship here. This is both on the products. So if this is X, then this is also X. Okay, but this is on the acetic acid is on the other side, so that has to be negative X. Right? So far, so good. Now you're going to add it together. So this will be 4.5 minus X. This will be X, and this will be X. Okay, so far, so good. So I'm going to fill it in now. So here's my K sub A. K sub A is 1.8 times 10 to the minus 5. And then I'm going to put the two that's on the right. So the two that's on the right are these two guys, the hydronium and the acetate. So that's here. That's X and X. So they both go on the top. So I have equals X times X on the top. On the bottom is the concentration, which is here, which is 4.5 minus X. All right, already I'm terrified. This looks like algebra 2, which I hate algebra 2, because if I were to put 4.5 minus X on the other side and then have X squared on one side and X on the other side, the only way that I could do this is the quadratic formula, which is everybody's terrified of that. So let me just ask myself a question first. This is a weak acid. A weak acid means that the K sub A is going to be very, 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 very little, like something to the -5 or something to the -9, something very, very small, 0.0009, probably to the thousandth place or the 10,000th place. So round upable, it would essentially be nothing. It's just tiny. So I'm just going to fudge this. All right, I love fudging. I'm just going to erase what I wrote here and act like it wasn't there. Now, you'll see that it's just going to round off anyway, but it saves me 15 minutes of math that I don't like, because now all I'm going to do is I'm going to say 4.5 times 1.8 times 10 to the -5 equals x squared, and then solve for that. My calculator can do that. Times 1.8 times 10 to the -5. X equals 9 times 10 to the -3. Okay, so tens, hundreds, thousands place, it would not even be 1 penny worth. It would just round away. Okay, all right, so far so good. Now I know what x is. And x, remember, is the concentration. Okay, so what is x? X is the concentration of the hydronium atom, or ion. The hydronium ion, that x is 9 times 10 to the -3, 0.003. So, what's my pH? My pH is just the negative log. So the pH is equal to the negative log of my concentration of hydronium. So 9.3 log, I have 2.045757, blah 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 blah. Now check for significant figures. Oh, round it to 1 decimal place. So 1 decimal place is 1 point past. So it's 2.04. So the pH is going to equal to 2.0. Okay. This is hard. This is absolutely high school. This is hard, and you have to practice this to get it. But to do it twice is to do it a lot easier than to do it once. So, well, let's just do it until we get it.